Hello, Maya. Everybody hates weighted averages. Everybody. So you're not alone in not quite understanding how to get there and where to get. But here's one secret. I'm going to give you three secrets. Secret one, always list what you know. Always list what you know. Well, I know I'm going to take some of cocoa A and I'm going to add it to cocoa B and I'm going to try to get my truffles. I know that. And it's going to be chocolate truffles. It's got to be a certain percentage of chocolate in the truffles. I also know that I'm going to end up with 500 grams of truffles. So we can say truffles is equal to 500 grams. I also know what percentage of cocoa I want in those final truffles. So put percentage in T. I know is, I think, 86%. Now I can express that as 0.86, but if you don't like percent decimals, just use 86. And so long as you use 86 for all of them, or like a full number for all of them, it'll work. Now clearly I've got to add a certain amount of cocoa from one and a certain amount of cocoa from another. And I know it ends up with the total grams of the cocoa of T. So I know this. That's one thing I know. If I can't suddenly come up with more grams of cocoa in the, you can't add 6 grams of or 600 grams of cocoa and end up with 500 grams of truffles. It's impossible. You can never add more weight of something and end up with a smaller weight. Yeah, some things shrink, but not that much. So I know whatever amount of A and B, I know it's going to add up in grams. So that's one equation. So that's equation one. But I don't know how much in grams. I don't know it. And I don't know B. But I do know the percentage that's in A. I can make either one the right one. Let's call 80 A percentage 99, and we're going to call B percentage the other percentage they give us 70. And here's secret number 2. When missing two variables, A and B are variables, essentially letters that represent numbers we don't know yet, you need two equations. Well, so far we only have one. So there's got to be a way of coming up with two equations. Let me introduce you to weighted values. If I have a box or two boxes and they both weigh 50 grams, and I have another box that weighs much more, this other one box is 500 grams. Sorry, I can't quite get it. Somebody's coughing in the background. This other box weighs 100 grams. You would not come up with the average weight of these three boxes. You would not do it like this. 100 plus 50, add that together, that's 150, and divide that by 2. The average weight is 75 grams. That's not the case. First of all, you divide it by 2. There's 3 objects. And second of all, you just only used 50 grams of one box. So it's quite obvious that if we were going to figure out the average weight, I'd add all weights. And I would have to divide by 3. And I discovered the average weight is 63.33 grams, or 66 grams actually. 6 repeated grams. Well, I want you to take note that 66.6 is much closer to 50 than it is to 100. And that's because I had two 50s in there. In other words, that weighted the average down. Pretend now I add a third box in here. Pretend I add a third 50 kilogram box in here. It's clear that I have to add those together the same way. I have a 50 plus a 50 plus a 50 plus 100. And I have 250, but this time I have 4 boxes. And it's clear now that the average is 62.5 grams. Now notice that the average went down. It went even closer to 50 because I had more 50s. I had 3 times 50 plus 1 times 100. So I essentially weighted it. I said, okay, I have this amount. And if I look at 3 boxes plus 1 box, they equal 4 boxes. 3 essentially out of 4 represents 75%. So 75% of my 50 gram boxes, and the 1 represents 0.25%. And that's another way of saying it. It's really just changing it to percentage instead of how many of the actual boxes there are. Either way works. I mean, it will come out either way that it works. I have one 100 box and I have three 50 boxes. That's going to add up and divide into, and then when I add them up and divide that all by 5, I get 62.5. If I do it with 0.75 times 50, which is 75%, plus 1% or 25% of 100, it's got to add up to 100%, 1, times whatever it's going to be. So if I do it like this, 0.75 times 50, 0.25 times this, I end up with this, 0.75 times 50 is 37.5. And 25% of this is 52, and it still adds up to 62.5. So we can see dividing it into percentages still works. Let's go even further. We're going to add another one of these boxes. And I'm going to just make it a bit smaller so that I can visually add it. And it's clear now that I have 3 boxes. 50 plus 50 plus 50. And I have 2 hundreds. But another way of saying that is I have 3 times 50 and plus 2 times 100s. And I could figure out the average. It's 150 plus 200. It's 350. And now I have to divide by the total number here. Well, I have 2 there and 5 and 3 there. I had a total of 5. And I discover that this is 70 grams. And suddenly I'm closer to the 100 because I added a 100 box. But another way to look at this is 3 plus 2 is equal to 5. And 3 out of 5 is 60%. And 2 out of 5 is 40%. And the weighted average could, instead of 3 times 50, be rewritten as 60%, which is 60% just means 60 over 100. You could do it like that, 60 over 100 times 50. Or you can just figure out what 60 over 100 is, which is 0.6 times 50, plus, and then what's 40%? It's 0.4 times 100. And we discover that 0.6 times 50 is 30. And we discover 0.4 times 100 is 40. And we discover this also adds up to 70 grams. And this is just converting that number into a percentage of the total. So it looks like if we know the percentage of a gram times a gram plus a percentage times a gram, we will get the average grams. Well, in this equation, they're tricky because they don't give you the weight of the boxes. They don't give you the weight of the boxes. Instead, they give you 2 boxes, which is kind of nice. They give you box A, and they tell you box A is a 99%er. So in other words, there's 99 of these boxes. There's 99 of these boxes, but they don't tell you the grams. That's the mystery. We don't know the A. We don't know the grams. And we don't know the grams of this second cocoa box that we're adding. It's B, but we do know how many of them there are. There's 70 of them. There's 70 of them. There's 99 of the A and there's 70 of the B's. We know that when we add up just their grams, which is A and B, we're supposed to end up with 500 grams. But using the method we had used before, I know that there's 99 A, so I would add up A 99 times. Or I could just say 99 times A. And then I'm going to add it up to B, which is 70 B's. And I'm going to end up with 100% because I didn't convert those to B's. So I got to figure out it's going to add up to 100% of my truffles. Because I'm going to end up with 100. I want to end up with 100% of my truffles. I don't want to, or actually no, they give you the truffles weight. It's not 100. They give it to you. They want you to end up with 86 truffles. My bad. I want you to end up with 86 truffles. So long as I do it like this, all I need to know is the grams. Well, they gave me the grams. They told me the grams is 500. But look at that. We have two missing things in this equation, and only one equation. But fortunately, we have a second equation up here. Well, I'm allowed to rearrange this equation any way I want. For instance, if I subtract B from both sides, I discover that these B's subtract. And now here's secret number 3. whatever you do to one side of an equation, you must do to the other. So, as long as you follow that rule, it's fine. So these b's cancel out, and I get a is equal to 500 minus b. Well, that's another version of a. It's a expressed as b. By the way, I could also rearrange it to discover that b is equal to 500 minus a. So this equation has what's called 3 variations, but it's all the same equation. This equation is the same as this equation is the same as this equation. But the benefit of, let's say, this one is wherever I see a here, I can do what's called substitution. I can replace where I see a with what it's equal to. If something's equal, you can be replaced. So that means I can just rewrite my 99 boxes of that cocoa with 500 minus b instead of a. And then I can just continue and leave b in here like this. And I get this. Now I should multiply 86 times my 500 grams to figure out what that is. Notice I left all my percentage as full numbers, and that's fine. So long as I leave them all in full numbers, I'm treating them like a number of boxes, right? So you get that. Well, we don't know b, but I can multiply this 99 times 500. And I believe I get 99 times 500 is 49,500. Minus 99b. Oh, is a my 99? Let me make sure my a is 99. Yeah, this will still work out. So 99b is minus 4, and then I discover that it's 99b. And actually, you know what? Just to make my life easier, I'm going to use this version instead, and you'll see why. Because I don't want to work with negative numbers. I'm going to use the smaller percentage, the 70% for b. And everywhere I see b, I'm going to replace it with my equivalent equation. So I got 99 times a plus 70 times b, but I'm going to replace b with my equivalent equation. And this is still 43,000 on the right. So I get 99a, and when I expand this, I get 35,000 minus 70a. Now, you have to learn distribution. When something is multiplying a bracket with minuses in it, it multiplies the first term, then it multiplies the second term, and essentially you should have the same. You should still have two terms, and the sign in between should still be the same unless this multiplier was negative. But generally, if this multiplier is positive, then the sign should be the same. So you get that is equal to 43,000. Now, you can see that you have apples on here. I have 99 apples minus 70 apples plus a number is equal to another number. And I can subtract those apples. I got 29 apples left plus 35,000. Now here's the other secret. Here's secret number 4 of algebra. Secret 4 of algebra is when you want to figure out a, tell the story of a in BEDMAS order. So that's brackets, exponents, division, multiplication, addition, and subtraction. So what's the story of what's happening to a in BEDMAS order? Well, there's no brackets, there's no exponents, there's no division. There is a multiplication. A is being multiplied by 29. Is there any other multiplication? No. So we can go to addition, subtraction. Is there any addition? Yes. 35,000 is being added to A, whatever A multiplier is. But it's being added. Now the secret to unraveling the formula is we must tell this story in the last step. We must take the last step and we must make it our step number 1, and we must do the reverse operation to both sides. So we take our last step, we make it our first step, and we're going to subtract, that's the reverse operation, 35,000 from both sides. And then we're going to look at our other next step up above it. Instead of multiplying by 29, we're going to divide both sides by 29. And if you follow this rule of how to unravel something of one variable, you can't go wrong. We now have a formula for how to deal with this formula. We're going to follow the steps in order. We're going to first subtract 35,000 from both sides. We clearly see on the right side the 35 thousandths cancel. That was the whole point. And then on the left side, we're left with this. We next have to follow the next step. We're done step A. We divide both sides by 29. It's clear on the right, sorry, there we go. It's clear on the right that they cancel. So I'm left with A is going to be equal to 8,000 divided by 29. You take out your trusty dusty calculator, you take 8,000 and you divide it by 29. And you get this, 27 point, oh, I did something wrong there. It's not 8,000. I probably did 800. 8,000 divided by 29. And you get 275.86. Now, your thing up above says round up to the nearest gram, which is there, which means no decibels. Because there's an 8 there, we're going to round it up to this. You might say, do I have to go through that for B? No, you can use one of your simpler equations right up here. One of your simpler equations. Well, if A plus B is equal to 500 grams, we know that 276 plus B is equal to 500 grams. We just subtract 276 from both sides. It's clear that these cancel on the left. And we can see that B is going to be 234 grams. And you might be tempted to stop there, but if you have time on a test, you should always verify, which means you're going to take this equation and you're going to look at right side, left side. So this right side of the equation is 43,000. And you're going to replace your A values with what you discovered them to be. So is 99 times 270, oh, I did, look at that, I did a wrong subtraction down here for B. B is not 234, it's 224. So that's how easy it can happen. 224. Because 500 minus 276 is 224, so that's the benefit of using a calculator. So looking at this again. For A, I'm claiming that A is 276 and B is 224. When I multiply the left side in my calculator, 99 times 276, I get this. And when I get 70 times 224, I get this. And I just have to see what they add up to. Now there will be a small error because there was rounding. When we rounded it up, we changed the results a little bit. Does it come close to the right side? Yes. This adds up to this. Does the left side equal right side? Close enough. That's called rounding errors. Had we taken more exact decimals of the grams, we wouldn't have that error. But left side equals right side. Therefore, A is 276 grams and B is 224 grams. That's how you prove it. And this is a good example of weighted. I can give you more examples if you want.